All right, guys, so for this question, it says factor m cubed minus 64. So what we're going to do is we're going to see if we have a GCF, and there's no GCF. It is two terms. So we check to see, is it a difference of squares or a sum or difference of cubes? It can't be a difference of squares because if you notice, the first term is a cube. So it can't be a difference of squares. So then we check to see, is it a sum or difference of cubes? And since it's a subtraction and they're both perfect cubes, we know it's a difference of cubes. So we know that m cubed is m times m times m, and 64 is 4 times 4 times 4. So we want to follow the pattern which says x cubed minus a cubed is equal to x minus a times x squared plus ax plus a squared. So our m is basically our x term and the 4 is the a. So wherever there's an x, you're putting an m, and wherever there's an a, you're putting a 4. So we're basically replacing all of these a's and x's with m's and 4's. So what it looks like is this when we factor it. And you can rewrite it as m to the third minus 4 to the third if you want to first, but that's not part of your answer. Your answer is m minus 4 times your x term squared, so m squared, plus 4 times m plus your 4 squared, which is 16. So that's your answer here. Now, we're going to take a look at the next one here. So this is lesson 13, Mastering Factoring, day 3. So we're going to take a look at a few more examples, and then you're going to have some problems to work on. So we are looking at this one, 16x squared minus 8x minus 3. So you're going to ask yourself the question, is 16, okay, so let's back up a bit. This is the third day, so these are questions you should be familiar with since we talked about this the first 2 days. So the first thing again is no GCF, 3 terms, leading coefficient is not 1. So what you could do here, one of your options is trial and error. We're not going to do trial and error because of the pattern that I showed you on the second day, actually. Mrs. Morris showed you this. So 16x squared is a perfect square of 4x quantity squared. And then you can write the linear term as a product of the perfect square factor in another number. So you can write 8x as 2 times 4x. So we're going to rewrite this problem as 4x quantity squared minus 2 times 4x minus 3. And then what you're going to do is let u equal 4x. So you'll replace the 4x with u, and you'll get u squared minus 2u minus 3. Then that's a little bit easier for us to factor because what we're looking for are factor pairs of -3 that add to give us a -2. So that would be a u minus 3 and a u plus 1. Because -3 times 1 is -3, and -3 plus 1 is -2. So we replace the u with 4x, and we get 4x minus 3 times 4x plus 1 as our final answer. Now, if you did trial and error, you of course would be able to work that out that way and get this answer. So if you need to pause, you can pause at any time, but I do want to remind you that there will be problems that you need to complete, and you do not get credit for this Nearpod lesson unless you do those questions. All right, x to the 6th minus 64. So there are a couple of different ways to do this because this is one of those rare situations where x to the 6th and 64 are actually both a difference of squares and a difference of cubes. So you kind of have to decide, how do I want to work it out? I will tell you, if you come across a situation like this where they are both a difference of squares and a difference of cubes, go with the difference of squares. And I'm going to show you why here. I'm going to show you both ways, but let's look at it as a difference of squares first. So what we see here is that this is a difference of squares because we can write x to the 6th as x to the 3rd times x to the 3rd, and 64 can be written as 8 times 8. So when we write it with the pattern of a difference of squares, it looks like this: x to the 3rd minus 8 and x to the 3rd plus 8. That's following the difference of squares pattern, which I'm going to write across the top for you here real quick. So then what we do is we look at that to see, can I factor this any further than what I've already done? And the answer to that is yes. This is a difference of cubes and this is a sum of cubes. So you have to follow those patterns, and I'm going to color code this so you can see what happens here. All right, so x cubed minus 8 is a difference of cubes. So we're going to factor that one following the difference of cubes pattern, which is let's see, x minus 2, and I'll write them over here to the side if you need to see them written out. X cubed is x times x times x, and 8 is 2 times 2 times 2. So your x term is the x and your a term is the 8. Remember the pattern for a difference of cubes. I just wrote it on the other slide. It is x minus a times x squared plus ax plus a squared. So it would be x minus 2 times x squared plus your x term times your a term, so 2 times x, plus your a term squared, so 2 squared is 4. Then when you look at the second one here, x cubed plus 8, that's in that orangish color, that's a sum of cubes. So we have to follow that pattern. So I'll do that in this orangish color. And basically with the sum of cubes, guys, it's pretty much the same thing, but the signs are what's different, like we talked about. So it's going to be my x term plus my a term. So x plus 2 times x squared minus 2 times x plus 4. So that's my answer, factoring it using a difference of squares first. And I'm going to slide this over a bit because I want to have room for our other problem. I am going to rewrite it so that we have the binomials first. So I'm just rewriting it so the binomials are first, and then I'll put the two trinomials. Okay, so the other way we're going to do this is with we're going to factor x cubed, I'm sorry, x to the 6th minus 64 as a difference of cubes. So you can see the difference. We really should get the same answer, right? Because it's the same problem. I'm just starting with difference of cubes first. So if you're a little confused when I said it's a difference of cubes, also here's why. Because x to the 6th can be written as a factor of x squared 3 times. And 64 can be written as 4 times 4 times 4. So that's why we can do it as a difference of cubes. So we know with the difference of cubes it's your x term minus your a term. So my x term, x squared, minus my a term of 4. Then I take my x term and I square it. So I'm squaring x squared plus my a term times x, so 4 times x squared, plus my a term squared, and my a term is 4, so 4 squared is 16. The only thing I need to make sure I do is the x squared squared, which would be x to the 4th. Now, when you look at that and you compare our answers, notice they're not the same, right? So why not? Well, this x squared minus 4 can be factored further as a difference of squares. I'm going to change that color so it's different than the other part so you can see how we factor it. So it factors as a difference of squares. And it factors into x plus 2 times x minus 2. And then we have that x to the 4th plus 4x squared plus 16. Looks like I'm running out of room, so let me slide this over a bit. Okay, so still our answers don't look the same. They're close, right? We have the x minus 2 and the x plus 2 here. But this x to the 4th plus 4x squared plus 16 isn't over here. Instead, I have two trinomials. So where does that come from? Well, if you look at x to the 4th plus 4x squared plus 16, the only way we could factor it is if we could find factor pairs of 16 that add to give us a 4. And there aren't any. So we don't have a way of factoring this. But if you were to multiply these two trinomials together, okay, what you would get is x to the 4th plus 4x squared plus 16. So these two answers are the same thing. It's just that x to the 4th plus 4x squared plus 16 has been factored because of the way we factored this in the beginning. We started with the difference of squares, so we were able to fully factor it, whereas if you start with it as a difference of cubes, you can't fully factor it. So just wanted you to see this one because it is different. It's a little bit, it's it's a lot, but it's a rare situation, but I wanted you to see it. So if you came across a problem where it was a difference of squares and a difference of cubes, you would want to factor it as a difference of squares first so that you can get it completely factored. All right, so let's keep going here and take a look at this one. 9x squared y squared minus 18xy plus 8. So no GCF, 3 terms. Leading coefficient is not 1. So this is where you would do trial and error. So what I want you to remember, guys, is that the extra variables doesn't change what we do. So it's still a situation where I could do trial and error if it's factorable. Or you can use that neat little pattern we talked about today, as long as the first term is a perfect square and the second term can be written as a product of the perfect square factor and another number. So let's check it out. So 9x squared y squared is a perfect square because it's 3xy times 3xy. And 18xy can be written as 6 times 3xy. So we let u equal 3xy, and we rewrite this problem as 3xy squared, which I didn't do that here, so let me show you, minus 6 times 3xy plus 8. So we're going to replace the 3xy with u. And then we have an easier problem to factor. So you're looking for factor pairs of 8 that add to give you a negative 6. So it would be u minus 4 and u minus 2. because -4 times -2 is 8, and -4 plus -2 is -6. So replace your u with 3xy, and this is what you get. All right, so that's that. Now, the next 3 you're going to do on your own. I will have the answer after each one so you can take a look at it. Of course, we're not doing breakout rooms because this is in Nearpod. So what I want you to do is you're going to work on this question. And again, you need to show your work or an explanation of as to how you get the answer. So doing the Nearpod lesson means that you're doing all of the questions that you're asked to do. And that's how you get the credit for doing this lesson today. So 9m squared minus 25n to the 4th p to the 6th is what you're working on. So here's how we factor it. So we check to see, is there a GCF? There's no GCF. It's 2 terms. So we check to see, is it a difference of squares? And it is a difference of squares. So my 9m squared is 3m times 3m. My 25n to the 4th, p to the 6th comes from 5n squared, p to the 3rd, times 5n squared, p to the 3rd. So to factor this, remember the pattern for a difference of squares. I'll write it at the bottom. So even though there's a lot more variables going on here, our pattern is still the same. Our x term is the 3m, and our a term is 5n squared p to the 3rd. So our answer is 3m minus 5n squared p to the 3rd, and 3m plus 5n squared p to the 3rd. All right, so for the next one, so again, that's our answer. Factor m to the 6th minus m to the 3rd minus 6. So this is the second problem I'm asking you to do on your own, and then you'll be able to check your answer with what I have up here on the board. So this is another one of those situations where you could use the handy dandy little shortcut of u. However, this one you wouldn't actually have to do that because you know that the first spots when this factors is going to be these two multiplied together have to give you m to the 6th. So it could only be m to the 3rd and m to the 3rd to give you m to the 6th, because remember we add the exponents when we're multiplying variables. So what we're looking for here are factor pairs of -6 that add to give us a -1. So that has to be a -3 and a +2. So those are the two numbers that we can add together, or I'm sorry, multiply together to get -6 and add to give us -1. So that would be our answer for this one. The last one is x to the 3rd, y to the 6th, plus 8z to the 3rd. So again, this looks tricky because there are a lot of variables going on, but you follow the factoring steps sheet. So you're going to try this on your own in Nearpod, and then you can check your answer. So this is a sum of cubes. There's no GCF. It's 2 terms. It can't be a difference of squares because of the plus, for one thing. Then we check to see if they're both perfect cubes, which they are. Because x to the 3rd times y to the 6th is xy squared times xy squared times xy squared. And 8z to the 3rd is 2z times 2z times 2z. So if you follow the sum of cubes formula, which you should have in your notes by now, guys. You should have in your notes from the other day. So my x term is the xy squared. So when I factor this, it'll be the x term, xy squared, plus my a term, 2z. Then my x term squared, so this is where we have to be careful because we're squaring xy squared, minus our a term, 2z, times our x term, xy squared, plus our a term, 2z squared. So this is what we get, xy squared plus 2z times xy squared squared is x squared y to the fourth. When I multiply 2z and xy squared, I get 2xy squared z. Usually variables are written in alphabetical order when you're multiplying them. And then 2z quantity squared is 4z squared, and that's our answer. Okay, so that is it. I want you to make sure that you're doing the lesson 13 homework sheet, the practice numbers 1H through L and 2 through 4. And I will see you guys on Tuesday, trying to keep all my days in order. The assignment for Monday is going to be Khan Academy, and it's going to be based on factoring. So there might be some factoring by grouping, some in difference of cubes, factoring perfect squares, a difference of squares, factoring with 3 terms where the leading coefficient is 1, where it's not 1. So it's basically a Khan Academy assignment on all the factoring that we've done. All right, guys, have a good weekend.